NASA unveils ambitious $30 billion plan for Artemis moon landing by 2026, a new era of lunar exploration. On February 7, 2025, NASA announced an ambitious plan to return humans to the moon by 2026 as part of its Artemis program. This monumental initiative, backed by a budget of approximately $30 billion, signifies a pivotal moment in lunar exploration, emphasizing not only a return to the moon but also the establishment of a sustainable human presence there. This effort is viewed as a stepping stone towards future manned missions to Mars. Overview of the Artemis program. The Artemis program, which was formally launched in 2020, aims to land the first woman and the next man on the lunar surface. The program's overarching goal is to explore the Moon's South Pole region, which is believed to contain vital resources such as water ice that could support long-term human habitation and serve as a launch point for deeper space exploration. Key developments. 1. Funding and contracts. NASA has recently awarded $24 million in contracts to 9 American companies as part of the Next Space Technologies for Exploration Partnership's Next Step program. This initiative is intended to support logistics and daily operations on the Moon's surface, enhancing capabilities for human exploration. The companies include prominent names like Blue Origin, Intuitive Machines, and Lockheed Martin, tasked with developing innovative solutions for mobility, logistics, and surface management. 2. Technological advancements. The contracts will focus on creating advanced robotics and autonomous systems essential for managing lunar logistics, surface cargo, and meeting astronaut needs. Nujad Maransi, Deputy Associate Administrator at NASA, highlighted the importance of these advancements in facilitating sustainable lunar exploration and fostering a growing deep space economy. 3. International and commercial collaboration. The Artemis program emphasizes collaboration with industry, academia, and international partners. This cooperative approach aims to refine the blueprint for crewed exploration and ensure a comprehensive strategy for future missions beyond the Moon. 4. Timeline of events. 2020, the Artemis program was announced, initially targeting a 2024 moon landing, which has since been adjusted to 2026. January 2025, contracts were awarded to various companies to enhance logistical capabilities for lunar missions. Future plans. The Artemis program is designed to pave the way for manned missions to Mars, leveraging the knowledge gained from lunar exploration. Sustainability and long-term goals. A significant aspect of the Artemis program is its focus on sustainability. NASA aims to create a long-term human presence on the Moon that supports ongoing exploration and research. The insights gained from these missions are expected to inform the strategies and technologies necessary for future Mars missions, reinforcing NASA's vision of expanding human presence in the solar system. Industry involvement. The involvement of multiple private companies in the Artemis program is a notable shift in NASA's approach to space exploration. The selected companies are tasked with developing innovative strategies for logistics and mobility solutions, contributing to a broader space economy. This collaboration not only fosters innovation but also enhances the capabilities of the U.S. space industry. Conclusion. NASA's Artemis program is set to usher in a new era of lunar exploration characterized by sustainability, technological innovation, and international collaboration. The ambitious $30 billion plan aims to not only return humans to the Moon but also establish a framework for future exploration of Mars and beyond. As the program progresses, it is expected to reshape our understanding of space and our place within it, making a profound impact on science, technology, and humanity's future in the cosmos. Counterintuitive information in the content. 1. Increased budget amid challenges. Despite previous delays and challenges in space exploration, NASA is committing a significant budget of $30 billion to the Artemis program. Usually one might expect budget cuts or a more conservative spend during uncertain times, yet NASA is choosing to invest heavily. indicating confidence in the program's potential and the necessity of lunar exploration as a stepping stone to Mars. 2. Emphasis on sustainability over immediate returns. The program focuses on establishing a sustainable human presence on the Moon rather than just achieving a one-time landing. This long-term vision contrasts with typical space missions that prioritize immediate technological achievements or scientific discoveries. The implication is that the Moon is seen as a critical base for future exploration rather than simply a target for human landing. 3. Diverse collaboration instead of sole NASA control. Traditional space missions were primarily driven by NASA alone. However, Artemis is heavily reliant on partnerships with private companies and international entities. This shift towards collaboration can be seen as counterintuitive since it dilutes NASA's direct control over the mission. Yet it also reflects a modern approach to leveraging diverse expertise and resources in space exploration. 4. A focus on logistics over exploration. While one might assume that a lunar mission's primary goal is exploration or scientific discovery, Artemis emphasizes logistics and daily operations on the lunar surface. The contracts awarded focus on managing everyday challenges, suggesting that the operational aspects of sustaining human life and work on the Moon are considered just as important, if not more so, than the exploration itself. 5. Long-term economic strategy. The Artemis program not only seeks to explore the Moon but also aims to lay the groundwork for a deep space economy. This focus on economic viability and commercial investment in space exploration is counterintuitive, as most people associate space missions with scientific exploration rather than economic endeavors. The idea that lunar missions could lead to a burgeoning economy and space challenges traditional views of space exploration as purely scientific. 6. International relations through space exploration. The Artemis program's collaborative approach includes international partners, which may counter the stereotype of space exploration as a competitive arena dominated by superpowers. This suggests that space missions can serve as a platform for global cooperation, challenging the notion that space exploration necessarily leads to geopolitical tension. 7. Technological innovation catalyst. The expectation might be that technology development for space missions is driven solely by the needs of astronauts and exploration. However, the Artemis program is positioning itself as a catalyst for broader technological innovation that could have applications beyond space exploration. This indicates that investments in space are seen as beneficial for terrestrial technology advancements, which is not always a commonly held view. These points illustrate how the Artemis program represents a shift in thinking about lunar exploration and space missions, challenging traditional paradigms and highlighting the multifaceted nature of modern space initiatives. The NASA Artemis program represents a pivotal shift in lunar exploration and human spaceflight, aiming to establish a sustainable presence on the Moon by 2026 and paving the way for future missions to Mars. While many aspects of the program have been widely reported, there are critical elements that are often overlooked yet hold significant implications for the future of space exploration. 1. The role of commercial partnerships. One of the most significant aspects of the Artemis program is the extensive collaboration with private companies. NASA awarded approximately $24 million in contracts to 9 American companies, including Blue Origin and Lockheed Martin, to develop logistics and operations for lunar missions. This emphasis on commercial partnerships is crucial for several reasons. Innovation acceleration. The involvement of private companies can lead to rapid innovation and development of new technologies. Companies like Blue Origin and Intuitive Machines are likely to introduce cutting-edge solutions that may not emerge from traditional government contracts. Economic growth. The deep space economy is expanding, and the Artemis program is a catalyst for economic opportunities in the aerospace sector. By fostering commercial involvement, NASA is not only addressing immediate needs for lunar logistics but also stimulating job creation and technological advancements in the U.S. economy. Long-term sustainability. Engaging commercial partners ensures that the infrastructure for lunar exploration can be maintained and expanded over time. This collaborative model contrasts with past approaches that relied heavily on government funding and resources, which can be subject to political fluctuations. 2. Focus on technological advancements. The contracts awarded under the Artemis program are not just about logistics, they include a strong emphasis on technology development, particularly in advanced robotics and autonomous systems. This focus is significant for several reasons. Increased efficiency. Autonomous systems can perform tasks on the lunar surface without direct human involvement. Increasing efficiency and safety for astronauts. This is especially critical given the harsh lunar environment where human presence will be limited. Adaptable solutions. The technology developed for lunar missions could have applications beyond the Moon, including Mars exploration and other deep space missions. The advancements in robotics and autonomous operations could redefine how humanity approaches extraterrestrial exploration. Resource management. Effective management of resources on the Moon, such as habitat maintenance, waste management, and logistics, is essential for long-term sustainability. The focus on technology will help ensure that astronauts have the necessary tools to thrive in a challenging environment. 3. International collaboration. While the Artemis program is largely a U.S.-led initiative, it emphasizes international collaboration, which is often underappreciated in discussions about space exploration. The significance of this aspect includes shared knowledge and resources. International partnerships allow for the sharing of knowledge, technology, and resources, which can enhance the overall capabilities of lunar missions. This collaboration can lead to more comprehensive and effective exploration strategies. Political unity. Space exploration can serve as a unifying endeavor among nations, promoting peaceful cooperation and collaboration in a domain that transcends national borders. This is particularly important in the context of geopolitical tensions, where space can become a platform for diplomacy. Global participation. Engaging countries from around the world in space exploration can inspire a new generation of scientists and engineers globally, fostering a sense of shared human achievement and responsibility in the exploration of space. 4. Long-term vision beyond the Moon. While the immediate goal of the Artemis program is to return humans to the Moon, its broader vision aims to prepare for human exploration of Mars. This long-term vision is significant for several reasons. Learning and adaptation. The Moon serves as a testing ground for technologies and strategies that will be crucial for Mars missions. Lessons learned from lunar exploration can inform everything from habitat design to life support systems needed for the more distant Martian environment. Establishing a presence. Establishing a sustainable presence on the Moon is viewed as a necessary step in humanity's journey to Mars. The experience gained will be invaluable in addressing the challenges of longer-duration space missions. Inspiring future generations. The ambitious goals of Artemis can inspire public interest and investment in space exploration, fostering a culture of curiosity and innovation. This is particularly important for engaging younger generations in STEM fields, which are vital for future advancements in space science. 5. Environmental considerations. The Artemis program's focus on sustainability extends beyond human presence on the Moon. It also encompasses environmental considerations. This aspect is often overlooked but is increasingly relevant in the context of space exploration. Sustainable practices. Developing sustainable practices for lunar exploration, such as waste management and resource utilization, will minimize the environmental impact on the Moon. These practices can serve as a model for responsible exploration of other celestial bodies. Resource utilization. The potential for in situ resource utilization (ISRU) on the Moon, such as extracting water from lunar ice, is critical for sustainability. This approach reduces the need to transport resources from Earth, making long-term missions more feasible. Planetary protection. As exploration expands, considerations around planetary protection become more important. Ensuring that lunar exploration does not contaminate the moon or affect future scientific research is vital for maintaining the integrity of extraterrestrial environments. In conclusion, while the Artemis program is often framed as a return to the moon, its implications extend far beyond that. The emphasis on commercial partnerships, technological advancements, international collaboration, a long-term vision for Mars, and environmental considerations are all critical components that deserve more attention. These elements are not only significant for the success of the Artemis mission but also for shaping the future of humanity's exploration of space. As we venture into this new era of lunar exploration, it is essential to recognize the interconnectedness of these factors and their potential to transform our understanding of and relationship with the cosmos. 1. Funding and contracts. The Artemis program's ambitious $30 billion plan highlights NASA's commitment to investing in lunar exploration. The recent awarding of approximately $24 million in contracts to 9 American companies illustrates a substantial investment in logistics and operational support for lunar missions. This funding not only aims to enhance the agency's capabilities in managing resources on the lunar surface but also emphasizes the role of private sector innovation in advancing space exploration. Companies like Blue Origin, Lockheed Martin, and Intuitive Machines are pivotal in developing solutions that address the challenges of sustaining human presence on the moon. 2. Technological advancements. The focus on advanced technologies such as robotics and autonomous systems is crucial for the success of future lunar missions. These technologies are essential for managing logistics, ensuring the safe transport of cargo, and addressing the everyday needs of astronauts on the moon. Nujad Marensi's insights on these advancements underscore the importance of not just immediate mission success but also the development of a sustainable framework for long-term lunar exploration and the broader deep space economy. 3. International and commercial collaboration. The Artemis program represents a paradigm shift in how space exploration is approached, emphasizing collaboration with international partners and the commercial sector. This strategy is vital for refining the overall blueprint for crewed space exploration. By fostering partnerships with various stakeholders, NASA aims to create a comprehensive approach that not only facilitates the return to the moon but also sets the stage for future human missions to Mars. This collaborative model reflects a growing recognition of the need for shared expertise and resources in pursuing ambitious space goals. 4. Timeline and future plans. The timeline of the Artemis program, starting from its announcement in 2020 to the anticipated lunar landings by 2026, illustrates NASA's strategic planning and adaptability in addressing challenges. The program's goals extend beyond lunar exploration. It is a stepping stone for manned missions to Mars. This timeline emphasizes the significance of lunar missions as a foundation for future interplanetary exploration, highlighting the interconnectedness of NASA's goals and the broader vision for human presence in deep space. 1. The Apollo Program 1961–1972. The Apollo program was a series of missions initiated by NASA with the primary goal of landing humans on the moon and safely returning them to Earth. The most notable mission, Apollo 11, successfully landed astronauts Neil Armstrong and Buzz Aldrin on the lunar surface on July 20, 1969. The Apollo program marked a significant achievement in space exploration, demonstrating technological advancements and international competition during the Cold War era, particularly the space race between the United States and the Soviet Union. Over the course of 6 successful lunar landings, Apollo contributed significantly to our understanding of the moon and showcased the potential for human space exploration. 2. The Space Shuttle Program 1981–2011. NASA's Space Shuttle program was designed to provide reusable spacecraft for transporting astronauts and cargo to low Earth orbit. It played a crucial role in building and maintaining the International Space Station (ISS) and facilitated numerous scientific missions, satellite launches, and technology demonstrations. The program faced challenges including the tragic losses of the Challenger in 1986 and Columbia in 2003. Despite these setbacks, the Space Shuttle program significantly advanced human spaceflight capabilities, paving the way for ongoing international collaboration in space exploration and establishing a robust framework for future missions beyond low Earth orbit. 3. The Mars Exploration Program 2003 present. NASA's Mars Exploration Program encompasses a series of robotic missions aimed at exploring Mars and understanding its geology, climate, and potential for past or present life. Key missions include the Mars rovers Spirit and Opportunity 2004, Curiosity 2012, and Perseverance 2020, each contributing valuable data about the Martian environment. This program has laid the groundwork for future human exploration of Mars by enhancing our understanding of the planet's conditions and resources. The Artemis program is seen as a stepping stone to Mars, utilizing the lessons learned from lunar exploration to inform future manned missions to the Red Planet. NASA's Artemis program represents a transformative leap into lunar exploration and sets the stage for future interplanetary endeavors, particularly to Mars. As the agency prepares to allocate approximately $30 billion to return humans to the Moon by 2026, several key predictions can be made about the future of lunar exploration and its implications. 1. Sustainable lunar presence by 2030. By the end of the decade, NASA aims to establish a sustainable human presence on the Moon. This includes the development of the Lunar Gateway, a space station in orbit around the Moon which will serve as a hub for astronauts traveling to and from the lunar surface. The establishment of lunar bases may also lead to ongoing research and resource extraction, making the Moon a vital outpost for future missions deeper into space. 2. Technological innovations. With significant investments in robotics, autonomous systems, and logistics through partnerships with private companies, we can expect breakthroughs that will redefine how humans conduct operations on the lunar surface. Advanced technologies developed during Artemis missions will likely find applications not only in space exploration but also in terrestrial industries, enhancing areas such as materials science, robotics, and artificial intelligence. 3. International collaboration. The Artemis program is set to enhance international cooperation in space exploration. With various countries expressing interest in supporting lunar missions, we may see new partnerships forming akin to the International Space Station model. This collaborative approach will help pool global resources and knowledge, fostering a shared goal of lunar exploration and potentially leading to governing frameworks for space activities. 4. Economic opportunities in space. The growing deep space economy will be fueled by the Artemis program as commercial partnerships pave the way for private companies to provide services such as lunar transportation, habitat construction, and resource extraction. This shift could give rise to new markets and job opportunities both in aerospace and related industries, stimulating economic growth on Earth. 5. Mars missions in the 2030s. Lessons learned from the Artemis missions will directly inform future missions to Mars. By the early 2030s, NASA may be poised to send crewed missions to the Martian surface, utilizing the Moon as a training ground for astronauts. The technologies and strategies developed for lunar exploration will help mitigate the risks associated with long-duration space travel and surface operations on Mars. 6. Scientific research and discovery. The Artemis program will enable unprecedented scientific research on the Moon, ranging from geological studies to astrobiology. The potential discovery of water ice in permanently shadowed craters, for instance, could have profound implications for future human habitation and resource utilization. Insights gained on the Moon will enhance our understanding of planetary formation and the history of our solar system. 7. Public engagement and inspiration. As missions unfold, public interest in space exploration is likely to surge. NASA's efforts to engage the public through educational initiatives and outreach will inspire a new generation of scientists, engineers, and enthusiasts. This engagement may lead to increased funding and support for space exploration initiatives, both governmental and private. 8. Policy and ethical considerations. As lunar activities expand, there will be growing discussions around the legal and ethical implications of space exploration, including issues of planetary protection, resource ownership, and potential colonization. Policymakers will need to develop frameworks that address these concerns, ensuring that exploration is conducted responsibly and sustainably. 9. Emergence of space tourism. The advancements in lunar logistics and infrastructure are likely to pave the way for space tourism, allowing private citizens to experience lunar missions through commercial partnerships. By the late 2020s or early 2030s, more wealthy individuals might have the opportunity to visit the moon, which could further drive investment and interest in space exploration. 10. Long-term vision for humanity in space. Ultimately, the Artemis program may serve as a cornerstone for humanity's long-term vision of becoming a multiplanetary species. The moon could act as a stepping stone, facilitating deeper exploration of the solar system, including Mars and potentially beyond to asteroids and other celestial bodies. This vision underscores the human desire to explore, understand, and inhabit new worlds. Conclusion. The Artemis program is more than just a plan to return humans to the moon. It is a comprehensive strategy that promises to reshape our understanding of space and our place within it. With a strong foundation laid through technological innovation, international collaboration, and economic opportunity, the future of lunar exploration looks promising. As we stand on the brink of this new era, humanity's aspirations in space are set to reach unprecedented heights, paving the way for a legacy of exploration that extends far beyond our moon.